So, thank you all for joining us tonight for the Ecology of Dead Wood with Ken Bevis. I'm so thrilled you're all here joining us. I hope this will be a great presentation for your personal preserves and learning more about the fascinating dead wood and why it's so awesome. I am just a few things on Zoom. First, I'm going to have us all muted during Ken's presentation just so that it can broadcast through pretty clearly. And if things get a little shaky and you still have your video on, if you turn it off, that might help it come through a little clearer. Those are located in the bottom left-hand side. And then throughout the presentation, if you have any questions or comments or just need to know, you can always type that in the chat box and hit enter, and that'll shoot off to us. And I'll be monitoring that throughout Ken's presentation, and we'll definitely have some time at the end here for some questions. So if you want to ask it in person yourself, we'll have some time at the end for that. But I am so thrilled to welcome Ken Bevis, the stewardship biologist from the Department of Natural Resources. He's a wonderful guy and a really fascinating speaker. He's been a lifelong hiker, hunter, fisherman, skier, bird watcher, and an avid naturalist. He's been here in Washington since the mid-'80s, studying all sorts of wonderful things. And he likes to help small landowners learn to manage their private forest land for wildlife and to really enhance their properties for that. So this is a great tie-in with our personal preserve. And with that, I'm going to pass it off to Ken.
Wow, Katie, that was very very kind. Thank you. Let's see here. All right, I'm going to try to change the way I'm looking at things here. There we go. Okay, Katie, I've got you over here on the side so I can see you and I can still see Judith, but you can hear me okay? Sounds okay? Okay, Judith is nodding. Good. So Judith, you can be quality control too. Excellent. Well, thank you so much. That's a kind introduction. I am indeed with the Department of Natural Resources, and we work with small forest landowners. And tonight I'm going to tell a story, sort of. Actually, there's stories embedded in kind of sciencey stuff and bird watching and forest ecology. And we came up with this little moniker, the Dead Trees Excellent Adventure. There's nothing bogus about dead wood, as a reference to that kind of campy 1980s movie. Remember Bill and Ted's Excellent Adventure? Judith, you remember that? Yeah, I see people nodding. It was really fun. And those guys would always say, excellent. So not many people know this, but they just did a sequel to Bill and Ted's Excellent Adventure, and they're doing a sequel to the sequel. So the last one was called Bill and Ted Face the Music. The next one's going to be called Bill and Ted Face the Snag. And it's going to be all about Bill and Ted going around looking at dead wood and woodpeckers and the ecology. And I totally made that up. Don't believe me there. So anyway, so that's the lead in. We've got about 22 million acres. Here's the commercial. There's a little ad here of forest land in the state of Washington, and small landowners like us, probably a lot of the people on the presentation here with your personal preserves own about 4.5 million acres around the state, which is a lot. And there's about 215,000 people who are the owners of this land. So it's quite a large number. And we, in our program, we reach probably 1,000 people a year, and that's it. So you start looking at that, it's like, oh, we're only 20 years behind. And so we are a resource. And these small lands are this kind of dark green color right here. So there's some definite areas where they're higher, what do you say, concentrations, like down here, Clark County, Lewis County, actually Pierce, there's quite a bit. Eastern King County, surprisingly, Snohomish, the islands, here's where you guys are. And up here in, well, here's Lummi right there. There's quite a few of these small landowners. Okay, turn off the mute, whoever that was. There you go, thank you. And lots over here in Northeast Washington. So these are the people that we work with. And there's Matt Preventure, who's probably going to give you a seminar here. This is Julie. She just has such a nice smile. She retired recently, but we help people write stewardship plans. So if you have a forest stewardship plan or a timber plan, whatever your county wants to call it, you get a substantial property tax break. And I bet some people here have one. I know, like Jan and Mike Moy have one. And anyway, we help people give advice. And I'm the wildlife habitat guy. We work with WSU Extension conservation districts, and I should have added in here land trust and other entities around that help people manage their land. So, Katie, are you a land trust per se? Yeah. Okay. Good. Yeah. Yep. Okay. Yeah, I can see. Oh, I like that. I like being able to see you. Good. Okay. There you go. So here's our contact information. And once you tap into us, it's really interesting because, you might talk to Matt about root rot or myself about habitat. And you say, well, how do I find out about? And we'll know who to send you to. And we just have a pretty cool network of people. So there you go. Okay. So now the presentation. Here's a little bit outline. I'm going to talk about the forest and how it changes. What is a tree? Sounds kind of obvious. The life cycle of dead trees, PCEs, primary carrier excavators, secondary species, down logs once it falls over. A little bit about forest management and land management in general across the state. And then I'm going to say something about fire and my own experience with it. And I should have put in here, right along in here, you get a song too. So here we go. Okay. So let's speak about forest in general. Just to start with, that forests are always changing. We think of them as being static, but they're basically slow motion growth, life, death, etc. Like this is about a 35-year-old alder stand, and look over here is an old Douglas fir snag that probably was there in the original forest like 150 years ago, still there. So this is Miller Sylvania Park down there near Olympia, which is a pretty remarkable little piece of forest. This was logged off in about 1880 to 90 and was let to regrow. So this is 120 to 30, 120 to 30-year-old naturally regrown forest. And I mean, gosh, it looks almost like old growth. Well, this is old growth. This is the Quinault rainforest, which is about an 800 to 1,000-year-old stand. Look at the gaps in here. This is really interesting because a really old forest where the trees have, grown, died, fallen down. Here's a big log right here. Often will have a really different canopy structure than younger forest. And so you start looking at the shape of the forest and how it's changing and how it got to where it is. Well, you go into an older forest and there's always these standing dead pieces of wood, like this snag right here that's got all this cool, soft, broken off pieces. And here's a smaller one in the down log. So that's just a constant presence in older stands. So let's talk about trees for a minute, because trees, we think of them as being, oh, I don't know, like okay, like an animal organism, like a human. All of our systems are integrated and they're all alive. There's cell division going on, and with a few exceptions, like your fingernails being a hard covering over the sensitive tip of your fingers. But everything else, your skin, your arteries, your blood vessels, your spleen, your what's that little thing, the appendix, all of that, they've all got something going on. Well, a tree, we think of them as being these holistic organisms like that, but they're really not. And they're habitat features that are three-dimensional with things living in and on them that change with time, back to that sequence of forest change. So a natural forest will have trees in all sorts of different ages and states of growth or decay. There'll be the understory tree, the mid-level tree. Once again, you might have a great big dead one here with a Peleated woodpecker. These are Peleated woodpecker excavations. And check this out. This is actually the same tree just right below it. And the Peleated, which I hope everybody knows what they are. They will. If you don't, by the end of this presentation, they will excavate deep into a stem like that to go after carpenter ants and wood boring insects that are way down in the middle of this great big stem here. And they have just these powerful excavators. So that's what's going on right here. In this particular stand, a tree might have had something happen to it. I don't know, if another tree fell on it, there was a fire. It could have healed scars like this, where the tree has actually grown over the place where the surface of the tree had been seared or maybe hit by lightning. I don't know, but here's a cedar that has the same thing. This is a clue that inside of this tree, there's probably some decay going on. So in the forest that we think of as being this continuous presence of, these living happy trees doing their well, trees die regularly, and they might die a few at a time, let's say from fungus, or it's usually insects and fungus in some combination of, and there might be like just a few scattered around over here, or you might get a whole bunch die at once, like from a fire as being the classic. Like this is actually from the Carlton complex. The Crown Fire went through there, I mean, killed the whole thing. This was a Douglas fir ponderosa pine stand that was kind of like, the happy green forest, but not anymore. Well, okay, so here we are. This is 1 year after Carlton came through, really close to Winthrop, and that stand of Douglas fir was completely killed. This is over near Republic, if you know where that is, on Highway 20. If you go straight over the mountains on Highway 20, you come down through the Methow, you go through the fake Western town, you get an ice cream at Sherry's. Uh, then you go over the loop, you go through Omak, you stop and go to the Stampede. Then you go up to Tenasket and you don't stop unless you need gas. And you hang a right and you go all the way over Sherman Pass coming down towards Kettle. This is just at Sherman Pass. And that fire, well, it was 1990. I found out. Well, look at the number of young green trees coming in. And this picture was taken, I think, 3 years ago. So this is 28 years. Yeah, I know more than that. Yeah, 28 years after the fire. Anybody been to Yellowstone since 1988? How many dead trees are there in Yellowstone still standing after that fire? It's a lot if you've been there, and if it's pretty cool actually. Or you could have a small scale mortality, like, or excuse me, not yeah, small scale and slow motion. Yeah, that's what I meant to say. In a wetter forest, root rot, and a lot of our stands in Western Washington are second growth, because it was all logged off in 1880 to 1925. The whole thing was logged, all the lowlands, all the islands. There are probably a few little pockets that they didn't get. But now those stands have grown back, maybe been logged again, grown back again, and they're in stem exclusion. They're actually in the development phase of the stand where they're starting to self thin. Remember that old growth stand with the gaps in it? And what happens is root rot will kill trees in these little pockets, and they do it in slow motion. It's pretty interesting. And I'm sure somebody in this room has root rot and they're wondering what to do about it. And that's a forestry question, lots of things. You might get wind throw. You guys get some hellacious windstorms sometimes. And on the coast in particular, this is a major cause of tree mortality. It'll snap trees off, it'll tip them over, that sort of thing. It happens inland too. So here's one near Colville where there was a wind throw event. There was almost like a what do you call that? A microburst going straight down, and it broke off about 30 acres of forest. So these are all different types of events that could cause tree mortality in that forest to those trees that we think of as being these kind of eternal organisms. And every now and then, I know you've seen this, you go out for a hike or something, and you find these really cool old broken off scarred up snags. Sometimes they've got burn marks. This one is really close to Stevens Pass. This gentleman's named Howard, and Howard wanted to show me the bear den. And sure enough, bears had been denning. I don't know about the winter, but they slept right in this tree that probably burned, I'm going to guess 200 years ago, 250 years ago even. So here's the point, is whatever the event, the wood persists. It always persists for a long time, even in really, really wet environments. I mean, think about wood. Why do we use it as a building material? Judith has a wood beam right behind her there, dried out, keep it out of the weather, and wood lasts a long time. And that is true in the ecosystem. So back to the tree as an organism. So what the heck is a tree? That is, it's a popsicle stick with a lollipop on top. That's how I used to draw them. But no, well, a tree is a uh, complex organism. Which parts of a tree are actually alive? So we look at this groovy diagram you probably remember from science class, and you separate the thing out. Well, if I was in person, I would hold up a tree cookie, but to be alive by definition is cell division, and some kind of metabolism, something going on in the cell. And the only parts of a tree that are doing that are, somebody knows, I'm going to pause because the smart kid, the one in the back, or the one second row who always answers the question knows the answer. The cambium right here. So right under the bark is the cambium layer, which has cell division going both directions. It's laying down xylem tissue, or is it here? The sapwood. So just inside of the cambium is this sapwood layer, and the sapwood or xylem moves water from the roots up the stem to the leaves to provide the leaves with H2O to do photosynthesis. And photosynthesis is a totally, if there's a miracle in the world, it's water and photosynthesis, because a plant takes CO2, carbon dioxide, and water and sunlight into the powerhouse of the leaf and turns it into itself. It actually builds itself from air and water. That's a good trick right there. Well, up there where it's doing the photosynthesis, the photosynthate, meaning the products, there's a whole bunch of them. And this is all those substances that actually build the tree itself. They go back down through the phloem, through the inner bark of the phloem. Well, and then in the middle, the pith, the center of a tree, is former xylem tissue that has clogged up with some kind of crystals or chemicals or whatever. And all of this wood is a series of pipes or tubes. They're called tracheids. They're long, skinny cells that lay adjacent to each other and move materials one direction or the other, or they just hold the tree up. So as a tree gets bigger, the outer part is the only part doing that conduction, and the middle becomes supporting tissue for the living cells in the leaves and the living cells in the root tips. So what's the rest of a tree? Well, it's mostly dead tissue. It's mostly wood. And what is wood? Well, wood, like I said, is these tubes, and some of them are being used. This is a cedar from a log deck over near Toledo. And look at this little wet part right here. That's the xylem. That's the sapwood. That's as wide as it was in this cedar tree. And this is really interesting too, that this tree had heart rot. Well, heart rot is a fungal infection in a tree that the tree is actually actively trying to compartmentalize and keep it from spreading, not always successfully. But a tree, the hollow tree, it doesn't care. Well, not that it has emotions. That's a really good question. Do trees have emotions? Secret Life of Trees. Write that one down, Katie, in the chat. That's a really interesting book, Secret Life of Trees. But anyway, trees have this ability to compartmentalize things that are attacking it, and I don't really like that word, that are influencing it, but most of a tree is dead tissue. So this is where we get to the life cycle of a dead tree, because here's your healthy green tree, beautiful specimen of larch. I love this picture because you can see the whole tree. This tree is like about 120 feet high, probably 36, 40 inches in diameter. And it's got really solid bark. It's got enough moisture to have really good resin ducts. So inside of a tree, it has these little, almost like balloons of resin that are ready. They're like guard dogs. And if something bad tries to burrow into the tree, like an insect, if the tree is strong enough, it'll spit them out. It'll actually block the insect that's trying to bore in there. Well, when a tree is drought stressed, those little guard dogs are weak and the bug gets in. And once the bug gets in, it starts to break down the cambium and all that of the tree. So something happens. A tree can't keep up. And like in Western Washington right now, we've got drought stress, or we had drought stress, we probably will again, on the cedar trees. And there's been lots of cedars dying hither and yon. And so what happens? So the tree can't defend itself anymore. And come on, baby, there you are. Well, right after it's dead, the fine twigs will still be on there. And the cambium is where there's all this sugar. There's all this really active I guess I need to learn my chemistry a little better, but the carbohydrate, the whole thing is carbohydrate, meaning it's carbon and hydrogen, but the sugars themselves are simpler and the bugs love them. So as soon as the tree dies, the tree gets a whole bunch of insects coming there to eat the cambium. And when you pull bark back and you see these little galleries, these are cambium eaters. This is the insects that came in quickly after death. Here's a freshly dead tree with fine branches. Actually, that one's been dead for a little bit. And when you see these holes, these little woodpecker excavations, these are either in the bark going after literally beetles that breed in the bark, or they're going after these guys. They're going after the cambium. And this only lasts about 2 or 3 years. And after the cambium is gone, the insects that are going in there are wood borers and deeper, basically things breaking down the wood. Now think about wood for a second. Sorry, I got to go back to this, not that one yet. That wood is a really good substrate for living things. I meant to say this with the live tree. And so, I mean, it's got little gaps in it. It's made out of carbon and water. It's carbohydrate. Anyway, it's a good place. And trees, when they're alive, they keep all these other organisms out, mostly, not all. But once they're dead, they can't. So here we go. So um, eventually the bark comes off, it breaks off. You might get a pileated woodpecker. This took decades. How long? Interesting question. Then softer and softer and softer. So you can look at it as a predictive sequence. This is from the Quinault rainforest. I love that nature trail out there on the south side of Lake Quinault because you go up through that big stand that I just had pictures of, and they got all these cool little interpretive signs talking about the forest and wildlife. But this one I thought was really interesting because this says approximate age since tree death. How do I make? Can you guys see exactly what's on my screen? Katie, so you have the four people over here to the side? Oh, you don't have that. Do you have the little screen sharing thing down here at the bottom that I can't make go away? How do I make that go away? Oh, there it is. All right, never mind. All right, I won't worry about it. So, uh, yeah, so look at this. So 2 years, they say 2 years with fine branches, 6 years. I think this is too quick. I think this is more like 20, but that's okay. You get the idea. Let's say that's 40 years, that's 70 years. Still, it's a long time for a tree to break down and turn into this. So falls over, becomes a log. Now we've got a whole nother set of decay things going on because the log breaks down differently than the vertical tree. It's in contact with the ground, so it's wetter, moister, and it can be this totally different substrate for plant life. It's like this all this moss on the log and no moss down here next to it. I just think that's so interesting. That the wood provides a different growth substrate than the soil itself. And this is the classic one, the nurse log, where the site in a west side forest is so lush, it's so lush that pretty much every square inch of ground has got something growing in it. Even if the plants are separated, the roots are in there. And it's really hard for a tree to get established. And the service of a log offers a really good opportunity because there's not as much competition from deep rooted stuff. So anyway, the log can be a substrate for all sorts of things. And then the wood breaks down and becomes soil. Now, smaller diameter pieces of wood and leaves and things will break down more quickly. But the wood itself takes a long time. I'm going to show you a couple interesting examples of old logs here that, they break apart. And it takes a long time, and it can take centuries. So you go out to an old growth forest, go out there to the Olympic Park, for example, and look across the forest floor, and it's really humpy. It's hummocky. What is that? It's old logs. It's logs in various states of moldering. If a fire came through, it would burn part of those logs, but it would not burn them completely up. It's really interesting. You look at pictures of even these recent West Side fires because of the way it goes through. Sometimes in really dry conditions, it will sit there and smolder and burn the whole log up, but usually not. Usually wood even persists through that. So these forest scientist types have created these guidebooks for describing decay conditions. And I put this in there because a lot of ecological stuff, like when you're working on your personal preserve, you're not going to be able to precisely measure very many things, but you are going to be able to place some subjective. I see, the science guy would say that's not subjective, that's kind of objective. So Katie and I could go out there and I'd say, well, Katie, that looks like a stage 4 snag right there. Put that on the data sheet. And Katie would go, no, no, it's almost all clean. There's hardly any bark on it. I'd say, no, no, there is no. And we'd have this really fun argument. And the way you solve those is paper, rock, scissors, just for a little sciencey thing there. But anyway, yeah, we do things like this. So that whole litany there, I didn't say much about habitat yet, but dead wood is essential to a naturally functioning forest. It's just the way the whole system is built. You know, trees grow, they die, they fall over, they rot away. Fire comes through, kills a bunch more, they fall over, they rot and die away. We didn't really fully appreciate this until probably, you know, the 1960s, 70s, 80s, when they started doing some forest ecology work, looking into soil mycorrhizal fungi and all these relationships. We've operated on a pretty. It's kind of interesting because we've made some rather. Oh, I don't know, coarse assumptions, but there's one point right there. And now we get to wildlife. It's great habitat. There's all kinds of stuff that live essentially in this deadwood habitat type, which totally makes sense when you consider the fact that it's so resilient, you know, that it's this long-term presence in the forest. And there's some really cool animals. And I have to say, when I, early in my forest wildlife career, I started looking at dead trees and it was like, those are so cool. And I actually did my master's on dead wood. So I'm going to tell you about that here in a minute. But here's a few of those species. So that primary cavity excavators, primary, that means first. These are the woodpeckers. And woodpecker, by the way, is a descriptive term of a group of species. They're in different genuses. There's, I think there's even some in different families if you're a zoology buff, but they're not, you know, it's like saying a duck. Well, a duck is a floating bird with a bill. A woodpecker is a tree climbing bird with this amazing sharp chisel tweezer that's attached to their skull. And the skull, I need to get a picture of a woodpecker skull because uh, the arrangement of the bones is such that it helps absorb the shock. This is a male Peleated. These are the big you hear them in the deep forest, about the size of a crow. Sometimes they're kind of fearless. It's really interesting. You can get kind of close to them sometimes. But again, that's a male because it has the red mustache and the red going all the way to the beak. They chisel into trees going like tuk, 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 tuk. If you ever watch a woodpecker, they'll hit from one side, then the other, then the other, then they'll flip the chip or they'll flick it. They do this like amazing flick thing. And so they'll go up a tree and you'll see them, they'll go up a tree and they'll what do you call it? Prospect. They'll acoustically prospect by tapping. And what they're feeling for is that insect gallery. And this is a totally fascinating adaptation here that the Peleated, and I said this earlier, will find a tree that has a colony of deep wood boring insects or carpenter ants, and they'll go back to the same, you know, hole, which are these big square ones. So that's how you can tell. Amazing bird. Why don't they get concussions? Would any woodpecker, does anybody know this? It's in the song. Okay, there's a clue in the song. But you think about what a woodpecker does. The impact of that head, and it's their head. Anyway, it's totally amazing. So when they find the insect cavern, they'll stick their beak in there and they run their tongue into the insect gallery and they find that little grub, skewer it. They have sticky saliva and barbs on the end of their tongue, and then they well, that tongue is twice as long as their beak. And this is roughly true of all woodpeckers. So their tongue is like that long. And it's kind of cartilaginous. It doesn't really fold up very well. It does a little bit. Where do you store that thing? Well, it goes through this special, what do you call it, passage that goes down from the back of their throat, and it wraps around their skull and anchors at their nose. And they shoot that tongue. It's like they can shoot it way the heck out, and you hardly ever see it because they're putting it down in the woods. So anyway, woodpecker tongues are one of the marvels of the world. This pileated was on the snag that I planted right outside of my office not long ago. Oh yeah, here's a wood boring insect next to my pet taxidermied pileated woodpecker that I borrowed from the Burke Museum. Actually, it's probably about 70-year-old piece of rotten taxidermy, but he rides around with me. If I was there in person, I'd bring him with me. But this is what they're going after. This is a flat-headed borer that actually was in the middle of a piece of firewood that I split, and it like this bug popped out. So there you go. And excuse me. And Woody Woodpecker, yes, was modeled after the pileated woodpecker. Cartoonist Burt Lance, I think that was his name, 1923, something like that. In the early days of motion pictures, he went on his honeymoon in the Sierra Nevada, and apparently a pileated woodpecker was like banging on the cabin that he and his new bride were staying in. And she said, "Why don't you do a cartoon about that guy? Listen." So that's where he came from. And look at that thing. I mean, really, it's a pretty good rendition, actually. So there you go. Oh yeah, here's the snag. So this is a snag that I actually, excuse me, planted right outside of my office so that I could watch the birds land on it. One morning, here he came. This was so cool. This guy flew up, and my wife is a photographer. And I like to imagine that he was listening for insects right here. He held his head like that. Anyway, we just got a really nice look at that totally cool bird. Some other woodpeckers, sapsuckers. I should put red-bellied sapsucker. No, what is it? What is it? Help me, bird watchers. Uh, not red naped. It's they're West Side sapsucker that make those rows. It'll come to me in a minute of sequential holes where they go after the sap. The hairy woodpecker, about the size of a robin, black and white, a little bit of red on the male. Here's the downy woodpecker. That's the little teeny guy that you see at your bird feeders. Sorry, get out of here. That you see at your bird feeders, your suet feeders, red-breasted nuthatch, the flicker, who sounds kind of like a pileated, but not really. Flickers live in more the open country and feed on ants, interestingly, down in the ground. So these are some other examples of the primary cavity excavators, and they all share a particular habit. And so these science people, they study primary cavity excavators, and this is a 278-page overblown paper with too many graphs and charts in it, and count them, four copies exist in the world. One of them, actually, and I have two of them. One was my personal one, and my mom had one, and I got hers. And there's two others. Anyway, but here it is. Primary cavity excavator birds and managed unfinished Grand Forest of Washington East Cascades. Catchy title, absolutely. I like to call it a classic, oh gosh, not digital, analog publication from the last century. We're working on the movie version. Katie, maybe you could help me with some casting. Yeah, exactly. We need some, like, I don't know, splashy sharp. Maybe this could tie into the Bill and Ted thing. I never thought of that, but here we go. And we have arrived at the cheeky part of the presentation, right? Now there's going to be a technical glitch here because when I reach the end of the verse, I have to lean forward and click the slide because my roadies are on strike and they weren't here tonight. So, okay. And so this, you can sing along if you want. Okay, so Katie's going to tell me if you can you hear the guitar? Okay, let's try first. I'm a woodpecker, the king of the trees. I got pattern brains, I do as I please. Hey, hey, I'm the king of the woods. I'm a crazy red hammer, I make cavities. Homes for you, homes for me. Hey, hey, I'm the king of the woods. Ooh, 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 ooh. I climb up the trees, tap and tappy tap. listening for that insect cave. And I find that hollow sound, I axe my way in, and I slip in my sticky tongue. Yum! Oh. I'm a woodpecker, the king of the trees. I got patty brains, I do as I please. Hey, hey! I'm the king of the woods. I'm a crazy red hammer, I make cavities. Homes for you, homes for me. Hey, hey! I'm the king of the woods. I got rhythm in my bones, I'm synchronized. I bang on the highest place I find. I play my licks, I whack my tricks, I bang on my tree drum. And sometimes I sing just for fun. Oh-da-da-ha-ha, oh-da-da-ha-ha. Oh, 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 oh no, technical meltdown. Help me, PowerPoint. Ah, there it is. Oh, ho-da-da-ha-ha, ho-da-da-ha-ha, wicka, 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 hey, hey, I'm the king of the woods. Ho-da-da-ha-ha, ho-da-da-ha-ha, wicka, 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 hey, hey, I'm the king of the woods. Rhythm break. Hey, hey, I'm the king of the woods. I'm a woodpecker, the king of the trees. I got patty brains, I do as I please. Hey, hey, I'm the king of the woods. Hey, hey, I'm the king of the woods. Hey, hey. That must have sounded adequate. Katie and Judith were smiling. Okay. Thank you. So go to I'm going to write this into the chat for you. Go to WSU Forest Stewardship. WSU Forestry Extension. Yeah, that's it. And Google my name. And one of our landowners, he made 2 music videos with that song and the bear song with photos, and the bear song in particular. Watch the bear song, because he put like his videos of bears in with my song. It is so fun. Yeah. So there you go. Yeah. So I have 2 public domain music videos. So I'm pretty proud of that. Yes. So there we go. Yeah, exactly. So there you go. Okay. So meanwhile, back at the science, that these primary cavity excavators, they make a new nest cavity every year, or they clean out an old one, but they must go in there, chisel, flick, and the male does most of the excavating, but they're looking for a tree in the proper condition to do this thing. And you see this little round hole, you just see that cavity entrance. We're going to get to that in a minute, but there's a lot going on inside of that tree. And so they chop, chop, chop. And I already said this, but they use that beak as a chisel and a tweezer. And then they picked the spot. There was a research project where they actually used engineering methods to measure the density of materials. I think this was so interesting because some snags get used for woodpecker cavities and others don't. And it's like, well, that one looks just right. What's wrong with it? Well, they found out that the trees chosen for cavities have denser wood on the outside. The middle is softer than the outside. So they have to go through the hard stuff into the soft stuff. And that's only a product of certain species, certain rot trajectories. Anyway, so I thought that was pretty cool. So the bird finds the right tree. Then he's got to go inside and somehow hollow the thing out without having free range for the whack. Pretty cool. I don't know. I don't know the detail of that. I've never gotten inside. It's a great place to raise a family. So, if you're lucky, you might get to watch a cavity and see them come back and feed like this. So you think about birds. Now, when a bird, or actually any wildlife, but when a bird is nesting, there's this period of time where the parents, some birds, both parents don't help, most do anyway, that there's those little teeny helpless babies, and they grow fast, I gotta say. But there's still this period of time where, oh my God, every predator in the world would love to come and eat either the eggs or the little babies. That's why birds hide when they're nesting. Food, water, cover. That's why they got to have a good place. This is a great place to raise a family because it's essentially a wooden stronghold with one entrance, and usually one of the parents is there with the young, except for when they get pretty big like this. And the parent has a chisel attached to the head of this powerful boom thing. And so if a bad guy came along and tried to eat those babies through the single entrance, we're talking one-eyed chipmunk. Like you would, they would be very, very effective at defending their. And so consequently, woodpeckers have a very high fledging rate for nesting. So they have a high proportion of their much higher proportion than like open cup nesters out on the end of a branch, say like a robin or a tanager or something like that. So it's a great place to raise a family. So the good cavity snags, and I say cavity snags, so I've come around to where when we're walking forest, what I'm really looking for are the cavity snags, the ones that are big enough, often have broken tops. They're often a little larger in diameter because then there's literally more wood to have these different conditions. Sometimes they're really rotten. Sometimes there'll be some with a whole bunch of cavities in them. Like look at this one, 1, 2, 3, 4, 5, 6. There's at least 6 visible. And what happens is they'll soften over time as they go down, and the woodpeckers will just move to the next spot that's the right condition. This is a large tree over near Tonasket, kind of near Tonasket. And this is a big tree, by the way. This is probably 4 feet in diameter, gosh, 150 feet high. The landowner, Lee Johnson, he said when he bought his property like 35 years before this picture that this tree looked like that. It basically already looked like that. And he almost cut it down for firewood. And then he noticed all these cavities and he's like, maybe I should leave. Well, holy smokes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's like 17 woodpecker cavities on this side of the tree. Pretty crazy. So that's a really, really valuable thing. Oh, and then 2 years ago, it finally fell over. And so it had been standing there for, I'm just going to say 100 years before Lee even met it. And then before that, it was a 250-year-old tree. So this tree finally fell over after about 350 to 400 years of presence in the forest. Pretty darn amazing. There's another one, the little broken top there. Here's one on a dry site, same kind of idea, lasts a long time. Here's one over on the Olympic Peninsula. So when the top breaks out of them, and this one's still standing, then they can last a long time because they don't have that weight. When a tree is alive, this is a longevity commentary, it's supple. You think about green wood, it'll bend, right? So the wind blows, it bends. When it dies, it becomes rigid. It's kind of like when we get old, we get kind of stiff, I can't bend as good. But they break. So the big windstorm comes, they'll snap off, and the bottom part, and those are really good habitat features. So woodpeckers make a new one most years, and they abandon the old ones, or somebody will get there and try to use it, and they're sought after by a whole bunch of species. These are the secondary cavity species. Food, water, cover, they're taking advantage of what the woodpeckers created. So bluebirds, that's a mountain bluebird in eastern Washington. Swallows, violet green and tree swallows. Kestrels, the sparrowhawk, that's a cavity nesting falcon. The smallest falcon nest in abandoned woodpecker cavities, particularly flicker cavities. Here's a bunch of others, the small birds, the chickadees, the wrens, the brown creepers. There's the swallow again. The little owls, like the saw-whet. And I know somebody in this room has had a screech owl, a saw-whet, maybe a pygmy owl on their property. And these are the little I call them the toot owls because all the little owls, they go, some version of and that's the saw-whet I just did. They just go on forever. Anyway, no owl in the world knows how to build a nest. And so these little owls are kind of cavity obligates. So they use them. Screech owl. There's this cool screech owl. Look how cryptic that thing is. You can hardly see it. So cool. Cavity nesting ducks. That always just cracks me up. It's like, why I would never think of a duck as nesting in a woodpecker cavity, but wood duck being the classic goldeneye, hooded mergansers. These are all cavity nesting birds, and they must be enough of those cavities out in the native forest for a whole set of waterfowl ducks to have adapted to nesting in cavities. Mammals, these kind of, bats love to roost in old woodpecker cavities or hollow trees. Martin, squirrels, Douglas squirrels. You have Douglas squirrels on Lummi. They're like one of my very, very favorite, what do we call it? Personal preserved species, because they don't have enormous territories. And if you have them, that means you've got enough mature trees and enough cavities around that these little those little rascals can be there. Flying squirrels. Anybody ever seen a flying squirrel? Do you have flying squirrels on Lummi? You don't know exactly that you might, and you don't know it. Nocturnal cavity dweller, big eyes, really a cool animal. Down logs, that I mentioned them earlier. This is also a great habitat feature for a whole different set of creatures. And say like the amphibians, the salamanders don't live in the treetops, and they really don't go up a snag very much. But once it falls down, hey, game on. Same thing for a lot of the small mammals, not all, but like say deer mice. That's a deer mice. They can live in little burrows under the down log. They can go right under the edge of the log as a highway. Oh, here's a couple of them. Yeah, some of the salamanders. Reptiles, your garter snakes might actually live in a down log. Ruffed grouse up on the tree. And it's moist, so that rotting wood holds moisture in the summer. And I know it's moist in your part of the world much of the year, but there is a dry season, and that downwood can really be helpful. There's a chorus frog that was under the bark of this. I was actually pulling the bark back to show it on a field day, and we were looking at these, the beetle galleries, and it's like, hey, there's a frog. So that was pretty cool. Yeah, moist. They last a long time. I've already said this, but so this is a down log, probably down, say, I don't know, 20 years, 15, 20. This one's been down like probably a century. This is in that same rainforest trail that I like so much. And they have this little sign there that basically tells you that this one has been down about 150 years. Look at the trees growing out of it. These are like 100-year-old trees, and you can still see the log. It's still there. Now, this is an interesting case study. This is out by Moclips. You know where Moclips is. Katie, you been to Moclips? It's at the southwest corner of the Olympic Peninsula. And as you can just envision, it's like way wet. This is wet. This is serious wet. And this was a spruce that was felled somewhere around the turn of the last century. I like to imagine it was one of those World War I airplane trees. And this nice landowner is putting her hand in the springboard hole there, where the old timey loggers did the zip zip thing. Well, so we know about when this tree was felled, and right behind this stump is this, and this is the butt log to that tree. So when they felled it, whatever year that was, they took most of it, but the bottom piece was left behind. It was too big. It was too heavy. The train was full. Who knows what happened? But we know when this is over 100 years later, and that log is still basically in its form. And that's a spruce, and spruce is a soft wood. So this just tells you how long it takes for wood to break down. It's just a great example. Important habitat. I think I've mentioned that deadwood is an important habitat. Breaks down even further down in the duff. Holy smokes, do this sometime. Just dig around in the duff and look for whatever you find. If you're really lucky, you might get a northwestern salamander or one of the other salamanders, but you'll always find millipedes and little springtaily things and termites and sometimes a worm. And maybe if you look long enough, you might come upon one of the little wiggly salamanders like that Insatina. I didn't take that picture, but this is an Insatina guarding its eggs down in some rotting wood. That's an amazing thing. That's a little type of salamander. And just kind of circling all the way back, you know, the fungal relationship to breaking down wood, these hyphae are all over the place. There's some statistic about how much of the biomass of a forest is in fungal mass, and it's really high, just in terms of sheer volume. And when you see the mushrooms, you're only seeing the fruiting body of all of this hyphae that's down there actually doing the work of breaking down the organic material that's been generated, you know, through photosynthesis through the forest. So the Pacific Northwest is kind of like the great kingdom of fungus, particularly over there in the moister forest. And you know, because how many months of the year is it really wet where you are? Probably what, 9 months? You know, in recent years, yeah, nine something. I mean, and that dry window is expanding slowly, but it's still pretty darn wet a lot of the time, and that's really good fungal conditions. So there you go. So that rotting wood, it kind of feeds the soil, and thus it feeds everything. So the ecological importance of the wood decay sequence is really high, and then the habitat value for certain wildlife species is just it's a really interesting and important piece of that story, but it's not the whole story. So that's why I'm saying the ecology of deadwood. So back to the wildlife thing though, there's about 25 to 40% of forest vertebrate species are dependent on deadwood for some part of their life cycle, whatever it is. And the list is long. You know, obviously the Peleated woodpeckers and the flying squirrels and the owls, et cetera, a lot of the salamanders, but it's a really high proportion. And that's why I emphasize it so much with the landowners, because what do we do when we manage forests? Well, we often remove trees, and we don't. How we do that is a decision that we get to make. Such trees are dead, true enough, but theirs is a lively death indeed, wrote Eliot Norse. So there you go. So last section, I'm almost done. I'm a little bit over time. I'm sorry, I'm having so much fun. I'm being a little long-winded. I'm watching Judith smile at my jokes, so I like that. I can't quite see Ellen. She's over there in the shadow, but and Katie's egging me on, so I like that. Yeah, so here we go. Okay, so now let's just talk about the human relationship that gets a little bit because you say, well, come on, Ken, aren't there plenty of them out there? I mean, yeah, I get it. These dead trees important for woodpeckers and squirrels and all that, but you know, there's lots of them. Look at all that forest. Well, not necessarily, because even a lot of our forest that's grown back into second growth and such hasn't reached the stage where a lot of that stuff has occurred. And then our management practices, this is a Weyerhaeuser clear cut, fairly, you know, actually, I don't know that it was Weyerhaeuser, I take that back, but this is a brand new clear cut. Look what's happened to the wood. Okay, there's a couple of logs there, not a leaf tree or a snag in sight. What's happening these days is our logging shows are often, and I hope there's nobody in here who's, you know, timber industry offended, but we're whole tree yarding. So we're harvesting with the snipper machine, and it goes on the ground in a pile. They come with a big set of tongs. They drag it to a central processing place and make an enormous pile out of the material that otherwise used to be left scattered around on the unit. Well, here's one wildlife tree right here down along the riparian buffer, and it's got a bald eagle nest right in the top of it. So also, we cut them down for hazard tree. We're afraid of them. We're afraid of having a standing dead tree near anything that it could fall on. And so we often remove them in the name of hazard. Firewood. I mean, and I've done it, would selectively get the big dead tree because you could split it into nice firewood, you know, to put in your wood stove and everything. And you do this long enough, and there will be stands, you'll see stands that really there's not much dead wood at all because we've removed it a little bit at a time as we went. Okay, got all that. Well, how many do we need? You know, come on, science guy, give us some answers. And there has been some attempts at doing this. And so it's actually frankly kind of complicated because depends what species you're looking at, depends on the timber type, et cetera. However, there's a few generalities that larger ones provide for more species. There's just more wood, there's more opportunity. There's soft ones, the ones that have been around for a while. Certain species will only use those just because, like, say, like a little chickadee that's got to get behind something, they can't necessarily use the big hard one. And some species, some tree species, I shouldn't use that word better, uh, res- proceed more in a more friendly manner to the species. In the state of Washington, and I'm going to give my agency a little bit of credit here because the Forest Practices Act, which has been a long, oh my God, complicated uh, product of a lot of litigation and compromises and blah blah blah. But we basically have a mandated set of best management practices that are applied on legal timber harvest on state and private land across the state. And there's a whole bunch of things in there, like the certain stream buffer, the size of the culvert, and it's actually kind of working. It's one of the most what's the word, effective forest practices set of rules in the whole country, which is just really interesting. And built into that is acknowledgement of this very thing that I've been talking about. And so they say, okay, we'll have 2 wildlife trees per acre, providing habitat for cavity nesting species. That's actually the wording in the rules, but it's really hard to enforce. What does that mean? Provide habitat for cavity nesting species. And the 2 loopholes. One is if you have like a riparian buffer, like that picture I just showed of that clear cut, and say it was a 50-acre clear cut. Okay, I need 100 trees. Oh, they're down there. They're down there by the river. And they'll count them. So, okay, great. And safety takes the precedence. And, if they're next to a landing or a road or something, down they come. So the intent is good, implementation, anyway. Now, let's switch a little bit though, because our small landowners, and I'll bet you the people creating their personal preserves have thought a lot about wildlife habitat and having nice, beautiful trees and all these great benefits to the forest. And our small landowners, those 215,000 people, whenever they do a survey of values, the top one is almost always beauty, aesthetics. Second can be privacy. Third is wildlife habitat, like out of 20 objectives. It's so interesting. And providing wildlife habitat is important. I put this in, this is a joke that even a DNR forester, that's Dan, can learn to appreciate a snag. So, you show them enough cool pictures and a woodpecker too, they'll come around. I like to tease Dan with that picture. So what do I say? Well, you know what? Try for 4 per acre. So let's say you have a 5-acre forest. 5 acres of forest. Your target could be having 4, and then count them because you can see them. And look for ones, only count them if they're, say, 10 inches in diameter and 8 feet high. That would be just kind of like something that's adequate to be a cavity snag. So know what the best strategy absolutely is, to know what a good one is and keep them around. Bigger's better. Broken tops are great. Any species, frankly, we'll take whatever we can get. It's like a cottonwood, sure. An alder, absolutely. Douglas fir, some are better. Cedar, Douglas fir, grand fir is actually a pretty good cavity tree. And the hardwoods, I'm down in the weeds here a little bit, but they're best when they're partially alive. Think about a big leaf maple with a dead top, and it's going to have a hole in it where something could live in it. If the hardwoods, cottonwoods and alders are particularly vulnerable to this. The roots rot out more quickly and they tip over. They become logs more quickly. But if they're still alive and they're partly dead, you'll get a wildlife tree function out of the dead portions of that live tree. So there you go. If you don't have them, you could create them. Not out of your very, very best trees, but like say you had a closed canopy, medium diameter Douglas fir stand that when you counted some trees, it's got 150 trees per acre. I bet you that's a pretty realistic description of some of the stands there on Lummi. Well, 150 trees per acre, how many snags you got? There's 2. Well, heck, all right, I could kill 2 trees. How could you kill them? And pick the ones that are distributed, whatever. Well, you could girdle them. This is a nice simple method. And you cut a strip through the bark. Usually really should be a little wider than this, but if you could get up in the top of the tree and do that, that would be great. But unless you're a skilled climber, don't do that. Or you could use a climber. The arborists, you ask an arborist to snag a tree for you as a verb. Oh, they love doing it. Most of them, you probably have some arborists around there who have done this. Katie's nodding. So there are examples of habitat trees created on private property out of hazard trees. So, yeah, I strongly suggest this. If you have a tree on your property that's died, and you're afraid it's going to fall in the garage or something, have your arborist shorten it up, like all the way down to a third of the height or something like that, where they essentially make a stub. They imitate this. They make a broken top snag. Get them to take their saw, rough it up a little bit. Oh, I got to digress. I saw this guy today. I did an errand to the bank, and I told him, I said, "Owen, you're going to be in my presentation tonight." So there he is. He's still doing this. Yeah, that was pretty cool. He goes, "Really?" So I should have sent him the link, but I forgot. But anyway, you're mimicking nature out of these trees that were otherwise hazard trees. Yeah, there he is. That's Owen working again. Look what happens too. Yeah, it's pretty cool. Okay, now if you're doing a harvest, you you probably will be using one of these felling machines. This is what happens all over the state now. And they have these masticator machines which grind trees up. So you could also do that. So you tell them, you say, okay, Mr. Harvest Guy, I want you to, let's see if I can make this work. There it is. All right, watch this. Okay, this is a felling machine in action. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, 1011, 1012, 1013, 1014. Boom. In 14 seconds. Oh, and by the way, this is a big machine. That's probably like 10 feet high right there. This thing has, if you've never looked at one, it has a rotary, like a like a sawmill blade in there that just goes. It's crazy powerful stuff. And it's way safer than logging used to be. If that tree fell on the cab, it would just bounce right off. So anyway, but have them do this. It works. And you drive around Washington, and every now and then you'll see some of these out in a harvest unit. And if you wonder where they came from, I always hope that they saw my presentation and then they did. But some people have been doing it for years, and it does work. Yep, but don't do it yourself. It's like, not like this, not the ladder in the bucket of the backhoe. It's like, no. Hire the professionals. It does work. So this was over at the Suncadia Resort next to Roslyn, and they made a whole bunch of these when they constructed the place. And here it is 20 years later, 21 years later, and they're full of cavities. It's so cool. So it works. So last thing, speaking about fires and their aftermath, which is, and sorry, I shouldn't speed. Are we okay? Everybody doing okay? I'm going a little bit over time. Katie, am I okay? Okay. Yeah, we're good. Yeah, I'm almost done. So this is a personal story, and this is about a fire where it came through and killed a lot of trees. Now, not always do fires kill all of the trees. The variable mortality is one of the really interesting outcomes of fires. So your deadwood creation isn't always 100%, and then as fires recover, it's really complex. Some areas you have a lot of survival. Other areas like this aspen stand, it killed everything, but it sprouted back from the roots. So fire is not an absolute, destruction. It's an interesting thing. So here's what happened. This is my place, our place, Terry and I. So we have 15 acres up here in the Methow. And this is looking off of our driveway up the hill. There's a neighbor's house right up there. And this picture was taken in, I think, 2010. And notice these open grown ponderosa pines. Look at this brush layer. Oh, baby. We had bitterbrush and serviceberry. This was like 6 foot high shrub layer. Really good habitat. We had nuthatches. We had evening grosbeaks, birders in the group. You look at this species list. A couple squirrels. Lots of hummingbirds, interestingly. I think they nested in the shrubs, and hardly any woodpeckers. Only had one snag on the property. We very seldom saw woodpeckers. Well, August 1st, 2014, a fire came through, and it was started by a flat tire on a trailer on the highway a mile from our house. It took it 45 minutes to get there. It burned right through. So that other picture was taken from right about there, facing the direction. And it just burned everything. These are those same pine trees. They didn't crown, they scorched, but they all died. Home survived, firefighters saved our house. That's a whole nother story that I don't like to tell, but they saved us and we're still there. Well, oh, here's Owen again doing the work. Had climbers come out, knock the tops out of some of them. Remember this tree right here to help them last longer. Now, this is from last spring. I took this picture. Here's the species list now. Kestrel, hairy woodpecker, Lewis's woodpecker, flickers, bluebirds, tree swallows, violet green swallows, pygmy nuthatches. These are all birds related to snags. And we had a whole species composition shift with the snag from the green forest to the snag forest. We have more birds now than we did with the green trees, which I just think is so interesting. And look at the shrub layer, side note, how it's recovered. This is like 6 years later, we've got all sorts of stuff sprouted back. It's pretty amazing. So here's that same tree. That tree that Owen topped, see the cavity right there? There was a kestrel nest in an old flicker cavity. Flickers made a new cavity. I wondered if it was because the kestrels kicked them out of that one. There was a third cavity down here that had a bluebird in it. So there was bluebird, flicker, and kestrel all nesting in the same tree. That's pretty cool. And so just a wonderful irony of the universe that the guy that studied snags all his whole career now, he owns a snag patch. It's like there's a sense of humor out there kicking around, I think. Yeah. So take home messages, almost done. Dead wood, important to forest ecosystems, provides crucial habitat for about a third of the species. It can be maintained in management. A healthy forest has dead wood, and dead trees are beautiful. They're really interesting. So one of your tasks as naturalists is, if whenever somebody is saying like, oh, that's so ugly, that snaggy thing, great strategy give this. You just start mentioning violet green swallows and woodpeckers and tell them some kind of a story about the cool birds that live in these things. Insist on maintaining these things everywhere. Like it's not a extra thing. It's not like a boutique exercise. We want our parks departments, our neighbors and everybody to routinely try to keep these things standing when they're not a real hazard. But if it's not, if it's not bugging anybody, it's out there. So there we go. Healthy forest. I got ahead of myself. A healthy forest. Everybody wants a healthy forest. It includes dead wood. It includes all of these species. You can have a feature like that. It's not a fire hazard. If it's in the right place, it's not a safety hazard, and it will. So thanks to photos for my wife. Do you guys know Greg Thompson? He lives up in your neck of the woods somewhere. He's a retired Woodland Park Zoo guy. Yeah, and WSU DNR. Here is my email address. Feel free to send me stories, good pictures, I don't know, questions. That's what we're here for. And oh yeah, there you go. That picture, I took that bluebird with my phone through a spotting scope. How about that? That is crazy. So yeah, I'd be happy to entertain a few questions. We can do it through. You could say it. I think people could say it, Katie, don't you? There's not.
Yeah, we've got a nice size group here that I think if people have a question for you, they can go ahead and unmute or turn your camera on and just hop in and ask your questions.
Oh,
I
good.
just
Okay.
want to say thank you though, Ken. That was so amazing.
Oh, fun. Oh, thank you. Oh, what fun. Thank you. Oh, yeah. I know I do have a lot of passion about this topic. And I think part of it comes from, having over the years just kind of witnessed our whole approach to red-breasted sapsucker. Yes, that's it. Thank you. Yeah. So sorry, I just opened up the chat. Do you want to do the couple of chat ones there are in there? And then we can go to live.
Sure. Yeah.
Okay.
So I think there was a comment about the red-breasted sapsucker, and some great compliments on your singing and your song, the
Thank you.
woodpecker song.
You got to watch the music video.
Jam.
You got to watch the video. Forestry Extension. Just Google that up. Yep. And by the way, I'm trying for 1 million hits on the bear song. So I want everybody to watch the bear song. And that's an inside joke because we had like over 1,000. Over 1,000 people had watched the bear video. Huh? So
Wow.
we only got 999,000 to go. So anyway, go ahead, Katie.
Nice. And then, so there's another comment in here just about Scenic Estates, which is one of the neighborhoods here on the island, that they did a firewise thinning where several large dug fir trees that were
Nice.
fading from root rot were chopped to create snags.
Nice. Do you
So
know who,
it's
do you
awesome to
know who,
see that.
Scott, do you know who the arborists were that did that? That's worth giving them some kudos. Good job, Scenic Estates. Nice. Yeah.
Yeah.
And glad you liked the song, Leslie. Okay, yeah, let's go live. I like that. I like that idea. Because we've got how many people? There's 17 of us. Yeah. Oh, easy.
Yeah. Anybody got any questions? Want to hop in
Eli-
and ask away?
Elizabeth is waving her hand.
Yeah, I have a question. I have, my husband and I have almost an acre, and we have a lot of Douglas fir. Some of them are very large. And we also have some snags. And I'm watching the snags to see whether or not we're getting any woodpeckers. We've seen one pileated pecking away on a log on the ground. But is there a way to enhance the snags to be able to encourage the cavity nesters to come there? Should we drill holes? We have hole saws. We could actually drill a huge hole saw if we needed to, but
you could. Well, okay, so I'll say this. The times I've seen where people have tried to make cavity starts, where they like get a big drill,
yeah.
and drill a hole, the woodpeckers don't take it up because, and now I know why, the softness of the interior wood wasn't right. It's like they find the wood that's correct. So if you, well, are these trees solid? Are they still a whole solid standing tree, or are they broken off?
Some of them have been both. There were some that we had to cut because they were hazard trees, but we left them, like 20 feet high.
Sweet. That's the best thing you could do, because the top of that tree is going to get moisture into the stem. That wood will basically conduct. So you could like actually make the top of them a little more concave to collect more water. So you want them to soften. And I used to think that it was useful to like scar up the bark and stuff. I don't think that anymore, because the bark itself helps keep the wood wet, moisture, and the bark itself is the outer layer of a lot of these cavity things. So it usually takes some years before they soften up enough to start getting the cavity use. Like the one that I showed at where I said Suncadia with the bluebird. It took like 13 years before they started to get a lot of cavities. And so you might just have to wait. It does take some time.
Okay, thank you.
Yeah.
Oh, wonderful.
Thanks for doing that. I'm so tickled that you already knew about that. Yeah.
Well, this was a wonderful presentation. Thank you.
Oh boy, thank you. Nice. Yeah, I did. I actually invented it a year ago for WSU. When COVID hit, we quit doing in-person things. And by the way, Matt and I were going to come up and do a live workshop on Lummi. Katie, were you organizing that? Was that you? Yeah. And
yeah, we were looking forward to it, and then
we still can.
COVID hit.
Let's do it in a year. Everybody get their shots. I got mine. So cool. Nice. Well, thank you. That was good. Great. Yeah. So this was the substitute. Oh, that's what I was going to say. So we did a webinar series for WSU last spring. And because I wasn't going anywhere, I had the time to like finally just let's just go to the ecology of dead wood. And it's been a really fun experience to get to try to explain that in the general sense. I think over here on the left, who is that? There was a question over there. Scott, did you have a question? I saw you waving your hand around.
I do, yeah. I just wondered if like invasive species like sparrows or starlings are significant competitors of the native cavity nesters.
That's a very good question. And it really depends where you are. Now, this observation that if you're in a setting where there's a fair amount of agriculture or small scale, even like backyard little farms with goats and chickens and stuff, then you're going to have a pretty significant load of starlings and English sparrows. And the English sparrows are really in settlements. When you get out there to, and I bet you in this group right here, if you live kind of out in the woods, you don't have English sparrows. You might have one every now and then, but you don't have a whole bunch of them. And the starlings they'll be on the edges. They won't go into the deep woods. So if you have a wood lot, you seldom will have a starling in there competing with the woodpeckers, deep in the woods. So yes, it is an issue. Frankly, I'm not sure there's much we can do about it. I mean, if you had a small enough woodlot and you were willing to use direct control, and quite honestly, I did this. For my little snack patch 2 years ago. The starlings, the suckers came in, and they chased one of the flickers away. I hope this doesn't offend anybody. I sat at the base of that tree with my shotgun, and I got them. I just like, I mean, and it worked. Their nest failed, and I felt a little bad. It's like, they were just trying to survive. So yes, Scott, I think it's not as big a problem as we would fear, only because so much of the landscape is more, I don't know what the word would be, remote. Not directly with like farmsteads and stuff. You could almost predict it.
But if there's a lot of edge, then it could be a problem, at least
Yes.
with some species. Yeah.
Yes, a lot of edge with subsidized habitats. Yeah. Are you a birder?
Yeah.
Yeah, okay. So you know what? Observe that. See if you spot that in your birding, where you see the starlings and the English sparrows, particularly in breeding season, because that's when it would be an issue,
Okay.
or a bigger issue.
I will look.
And somebody said that flying squirrels do occur on Lummi. Nice. That doesn't, I mean, yeah, you saw that, Elizabeth. Did you see it yourself, or was it like a naturalist report? Or?
I've seen, well, I've had some people say that there are flying squirrels on the island. I'm not sure there are, but I'd like to think that there are. There are squirrels, of course. Yeah. But I had a comment about crows and ravens on the island. I think what's happening here is that we're getting more crows, which are normally seen in more urban areas. In our lot in the middle part of the island, there's been some more development lately in the last few years, and a lot more older trees cut down, and the crows are moving in and pushing the ravens out to the more wooded areas. And I've seen some conflict between the crows and the ravens recently, where the crows have been harassing the ravens. And normally you get ravens in more wooded areas, wilderness areas, forests, and crows are more inner city, or in our case, on the island, they hang around the ferry area where there's more houses and fewer trees. They're sort of encroaching into the raven territory.
Did you read Marsluff's book, In the Company of Crows and Ravens?
Yes, and then several, yeah.
It kind of addresses that directly. Like, there used to be a species called the northwestern crow that was associated with the coast, and the eastern crow didn't really interact with them because there was so much deep forest in between. And then with settlement, the common crow has moved over and essentially interbred with the northwestern crow to where it really may not exist anymore. It's pretty interesting. Yeah, these outcomes of humanity. But you can't say that settlement is universally always bad for wildlife just because you can't lump all wildlife together. You have to segregate it out. If you were an English sparrow, man, there's nothing better than town, or a starling for that matter, or an eastern gray squirrel. You have eastern gray squirrels on Lummi?
No.
You don't? Wow, interesting. But you do right over the water in Bellingham.
Right.
I'm sure. And are they in town? Are they out of town, or they're not on Lummi? Interesting. What else? Do you have foxes?
There's a few that have been seen over the years. I've seen them, but people have said that they came from the attempt to raise foxes on the islands.
Yeah.
And
How
we
about
do have a few coyotes. There were more here 20 years ago than there are now, but I've taken a few photos of them when I've seen them.
nice. How about possums?
No, no possums.
No possums.
Lots of raccoons.
You have rabbits?
Yes,
Which kind? The cottontails or the big, like the big hares, like out on the San Juans?
I think they're cottontails. I'm
Little,
not sure.
little white, little brown guys with the little white tail. Yeah. Okay. Yeah.
Yeah.
Those are cottontails. Cool. Bobcats. Yes, you have bobcats.
No, no bobcats.
No?
No.
No bobcats. All right. I wanted some trail cameras out. That'd be interesting. Cool. No. Okay. Yeah. The islands, the whole archipelago there, it's so interesting. And you have lots of deer
Yes, too many.
with no
Yeah.
predators other than coyotes on the fawns. Yeah. You go out to, is your understory browsed out by the deer?
Yes,
Yes.
Yes. Okay. Yeah. I got a chance to go to Waldron. You know where Waldron is?
yes.
Mhm.
They shoot all the deer when they get there, right?
Yes, there's no deer on Waldron. They have a long-standing eradication campaign, and you like the people on Waldron don't have fences around their gardens.
Yeah.
It's like, really? And if a deer shows up, they shoot it. Yeah. It is that's really interesting. And so the effect on the understory vegetative composition, yeah, in the absence of deer it's really striking. Go on to Orcas or San Juan. It's like it looks like it's covered with goats. Pretty interesting. Well,
So could I ask just another question?
oh yeah, absolutely.
So Ken, we just finished an inventory of one of the preserves on Lummi Island, one of the Heritage Trust preserves, a forest inventory, and we looked at regeneration as well. And we, out of 70 or 80 plots, we did not find any Western red cedar seedlings.
Oh, really?
Not
Sure.
one.
But there's a Western red cedar in the overstory.
Yes.
I
And
bet
there are a few saplings that are 15, 20 feet. Well, fair number of saplings, but no seedlings.
Interesting. How old were the saplings?
That's a good question. We haven't cored them yet, but yeah, I assume 20, 30 years.
So would 20 or 30
Understory for a long time.
Yeah, I was going to say, would 20 or 30 years ago be when the deer population started to go up I'm going to be candid, as human habits changed and people weren't shooting them as often? Because we've had a cultural shift where it wasn't that long ago where it was routine for rural people to, shoot deer and eat them. And we don't do that as much. We don't do it at any level of significant predation in much of the state now. I don't know, Scott. I bet it's the deer herbivory. I'll bet
Yeah, that's the theory, and my concern is we're now losing a major component of succession, of forest succession.
Yes.
Major component of the species component.
When you have Matt or myself or a forester come out, we are constantly recommending underplanting cedar with cages on them in order to basically, establish that understory cohort, because most people with small parcels, they're not going to clear cut. They might harvest. A lot of us would harvest a few trees and maybe have some supplemental income, but we still want it to look like a forest. And if you have the overstory and you remove a few of those, you got to get your understory coming in. And if it's going to be in a forested setting, they've got to be shade tolerant, which means cedars or gram fir. Yeah. Put a cage on them. Yeah. Interesting. And so, Scott, you could test that herbivory theory with exclosures and then plant a few. Plant some in and out of an exclosure and then put a little fence around it and see what happens in 5 years.
Okay, we will do that. Sounds good.
But timber tree arborist. Okay, we like those guys. Hire them. Cool. Well, very good. Well, I have gone way over time here, Katie. I apologize, but what fun. What a wonderful audience. This feels like hanging out with all my favorite naturalist friends. Yay.
Yeah, thank you so much, Ken. This was so interesting. I learned so much. I'm
Oh,
like,
fun.
can't wait to pick up a book and read more about woodpeckers and their different habitats, and just to
Nice.
go out in the woods and enjoy all the snags and dead wood and have a deeper appreciation for them now.
Oh, I appreciate that. Yeah, The Secret Life of Trees. That is a good read. Oh, I just read another one not long ago. It was by Stephen Arno. It was about Douglas fir. It was just called Douglas fir, the amazing tree. Well, very good. Well, good luck with the rest. Oh, look, Elizabeth, the nature of oaks. Okay. I
Yeah.
have a sense that Elizabeth is a deep file for what good reads are. Thank you.
I'm learning a lot about trees because of Scott.
Nice. How fun. Well, very good. Well, okay. Well, thanks again for having me. What fun. And I look forward to our in-person workshop. Reach out to Matt and myself, and maybe we could get another trip up there to Lummi sometime after we all get our shots. And see, I'm counting on wearing out my mask. I'm going to keep wearing it till the sucker just falls off.
You ought to clean it occasionally.
That's right, exactly. Okay. Well,
Thanks so much, Ken.
Thanks, everyone.
hey, thank you.
Terrific presentation.
Thanks,
Yeah.
Ken.
Excellent. Thank you, Scott. And thanks, everybody. Okay. Take care. I'm waiting for Katie to, yeah.